Mr. Garneau is a sustainable energy consultant with ECONOLER, and ECONOLER has been working with the DFC for the past 2.5 years, providing support for us to be able to more effectively deliver sustainable energy products to the Belizean public. Welcome.
Thank you, Hip. Yes, so oh, I need, oh, is it? How is it open? Is the battery on? It seems to be. Okay, so yes, so as mentioned, I'm Yann Garneau. I work for a company called ECONOLER. So we work in the energy and is it okay? Yeah, it's fine. Energy and climate sectors. So we're working in many different countries, working on different types of projects. And so as part of the project in Belize, we were helping DFC to improve their green finance offerings in terms of renewable energy and energy efficiency. So under the Eco Micro project, which is an initiative from the IDB Lab with funding from the government of Canada. So as part of that project, we did sort of a market study in Belize to identify energy efficiency and renewable energy potential in different sectors. And so we identified priority sectors and technologies which couldn't be implemented in the country. So these include offices, fisheries, agriculture, manufacturing and processing, agro-processing, food distribution and retail, and then on-grid and off-grid hotels. So we also see here all of the technologies that were identified as having a higher potential. We can see for the on-grid hotels that there's potential for energy efficiency, but usually limited solar PV potential, because there's sort of some electricity consumption during the day, but without a feed-in tariff, there should be proper sizing of the solar PV equipment. So now we're going to look at some energy efficiency parameters in the productive sector, so some examples of different sectors. So here we have an example for offices, so both in commercial and institutional sectors. So we have here sort of the typical energy and water cost breakdown for a typical office. So it would be about $8 Belize per square feet per year. So this would be sort of the baseline energy cost. So we can see that most of the energy is going to electricity. We have some for diesel generators, gasoline vehicles are owned by the company, and then some consumption for water and sewage. And usually the business operating costs would be about 15% of the company operating costs. Yeah. Then if we take the electricity consumption of the building, next, we can see again what would be the typical electricity usage breakdown for the building. So we have about 14 kilowatt hour per square foot as a baseline, and then typically you will have 45% potential in energy savings by doing energy efficiency projects. So this obviously excludes solar PV. So with solar PV, you could further reduce your energy consumption. And so this is kind of the kind of information that you would obtain from doing an energy audits with the energy service companies inside your building. So you could assess what are your current baseline energy consumption, and then the ESCOs can help you identify potential energy saving measures for your building or your company. So we can do this also for hotels. So we have here would be maybe 60% electricity. We have also diesel consumption and water consumption as well. And usually this would represent 5 to 10% of a hotel's operating costs. And then again, we can look at the electricity consumption for the hotels. So again, we can see for hotels we usually use kilowatt hour per room night. So if there's a client spending one night at the hotel, then we will have a typical kilowatt hour electricity consumption for booking one room night. And so again, the baseline would be 45 kilowatt hour per room night, and then there's typical potential savings of 40%, again excluding solar PV. And we can see the energy audit also allows to see what's the share of energy consumption going to the different end uses, so lighting, air conditioning, refrigeration, kitchen, hot water, etc. Then again, we have here supermarkets. So the sort of baseline energy consumption energy cost would be also in Belize dollar per square feet, and again, maybe 5 to 15% of a business operating cost. And then we can look at electricity again. So pretty much the same thing here. Next we have the retail stores. So again, we can establish a benchmark cost and energy consumption per square foot of building. So again, 5 to 15% of business operating costs. And look at the electricity consumption. So you could have an energy audit and then compare what is your current electricity consumption to these sort of benchmarking values of baseline and more efficient retail or hardware store in this case. So next we're gonna look at some of the most common EE and RE technologies in the productive sector. So I'll go quickly through the slides because we have more people presenting, but I guess we can share the slides with the people afterwards if you want to have a look into more details. But so for lighting, usually we try to implement lighting controls. So this could be occupancy sensors. There's also daylight sensors, which are which can be used, and they'll sort of adjust the lighting to the daylight that enters inside the building. In terms of lighting efficiency, product quality can be an issue. Both in terms of efficiency and lifetime. You also have to look at the color temperature of the equipment because the efficiency will vary according to the color temperature. So you usually want maybe a lower color temperature will give a better lighting, but the higher efficiency products are usually a more blue light than the lower or warmer color temperature. So we have here some typical costs for LED light. Then So here we can see what would be sort of a typical simple payback period for example, replacing a CFL, not replacing, but purchasing an LED instead of a CFL. So maybe end-of-life replacement, you have to choose between a CFL and a LED. So the incremental cost of buying the LED is what should be looked at in terms of energy efficiency project. But we can see in the table here that LED light will have maybe 5 to 10 times more hours as a typical lifetime. So in addition to the energy savings, you also have to consider the lifetime of the product. And then the other example is replacement of T8 fluorescent light to LED tubes. In this case, we're considering early replacement, meaning that your lighting is already in place, and then you're replacing the LEDs, so the full cost of LED should be considered. So in this case, the simple payback is a bit higher. The split AC units, so the typical efficiency unit to be looked at is the seasonal energy efficiency ratio. And so a typical low quality split AC unit will have an SEER of 9 to 11, and then you can, which has a SEER of 17 to 20. And this would be type equipment, so that the motor has sort of a variable speed capacity. And usually the life expectancy of those products are about 15 years. So if your split AC unit is 20 years old, then it would be a good time maybe to replace it. And also the efficiency goes down as the years pass by. So here again we have two examples. So if you're doing sort of an early replacement of an inefficient unit, you're looking at the full cost of the equipment. So the payback period might be 5 to 7 years. But if you're doing sort of an end-of-life replacement, you need to look at the sort of incremental cost of the product, which is in this case about 300 to 600 Belize dollar per ton of capacity, and 1 ton is about 12,000 BTU per hour. So next. Then we have commercial refrigeration. So here we can improve the energy efficiency by purchasing efficient equipment, which has LED lighting, better controls, and also high efficiency compressors and motors, and as well as increased insulation. In this case, we're looking at the energy efficiency ratio of the equipment, and also the lower the temperature of these equipment, the lower the energy efficiency ratio will be. So it's important. If it's a low temperature equipment, then the savings will be higher if you implement projects. So we're looking at maybe a payback period of 3 to 5 years when considering the incremental cost of products. Oh, can you go back one slide? Yeah. Motor system. So we can look for motors that, well, they're used for different applications. In terms of energy efficiency, they're usually rated using the IEC standard. You can also implement variable speed drives to control motor speeds. So we have here sort of typical efficient motor cost, and then savings potential in terms of this is when including both motor and variable speed drives and better controls for motors. Next. So again, for motors, we're looking at if you're only replacing the motor, maybe a 5 to 10% increase in energy efficiency. So this depends on the size of the motor. So the smaller motors usually have lower efficiency, and higher capacity motors will have sort of a higher efficiency. But for a particular output of the motor, you'll have different energy efficiency classes. So again, we can look at sort of early replacement of a motor, which will have a simple payback period of about 6 to 8 years. And if you're doing the end-of-life replacement, for example, purchasing an IE4 motor instead of an IE1 motor, then you'll be looking at a simple payback period of about 2 to 4 years. So here we have an example of inefficient pumping system. So there's many different components in a pumping system. So if your motor is inefficient, your coupling is inefficient, your pump is inefficient, you're throttling the flow of your pumping system, and then maybe your pipes are undersized or they have clogging within them, then you're maybe looking at the 31% overall efficiency. And then if you sort of replace the system with a more efficient motor, you add the variable speed drive, and you increase the pump efficiency as well as improve your piping system, then you could increase the overall efficiency to something closer to 70% efficiency. Next. Then we have energy and water. Water use. So, what are the water-saving measures which can be implemented? So we have some in terms of water supply. So rainwater harvesting, running reverse osmosis plant during off-peak hours, and then a few measures regarding swimming pools and spas. So here we can see some other water conservation measures. So with the typical sort of baseline gallons per minute, for example, for shower heads and faucets, we can also look at water closets, urinals, washing machines, again, kitchen faucets, commercial dishwashers, and also water efficient landscaping. So these are all measures which can be implemented, and the reduction in water consumption is quite high, so maybe 50 to 70% reduction. So it's quite interesting to implement those. Then we have solar water heating. Oh, Maritza, one back, please. Yes, so solar water heating, again, many different applications, so hotels, restaurants, gyms, pools, laundry, agro-processing, industry, etc. So, and we have local technology providers which can help you with installing and purchasing those equipment, and the simple payback period will be about maybe 3 to 5 years, depending on the applications. Then for solar PV panels, so typically solar panels will have a efficiency of about 15 to 20%, depending on the quality of the product. Some high quality, like really high quality products will have efficiency up to 22%, and every year they're sort of increasing these numbers while the costs are decreasing. So maybe you have looked at the possible project 3 years ago, and it would be a good idea to sort of reassess, because the costs are going down and the energy prices are going up. So maybe solar PV panels would be a good investment. And usually the life expectancy of those products are quite high. So we're talking about 20 years for the solar panels, and this can be even higher with proper maintenance. And inverters will have a lifetime of about 10 years. And so when looking at the simple payback periods for solar PV, it could differ from anywhere from 5 to 10 years, depending on the location, the efficiency, and the cost of the project. So, yeah, next. So we can see here sort of a map of Belize with the potential for solar PV systems. So we can see that there's high potential everywhere in Belize. The potential might be a little bit higher close to the... Okay. Potential might be a little bit higher in the coastal area, the islands, but still, so we're looking at maybe around 1,500 kilowatt hour per kilowatt peak installed system, and the cost maybe about $2,000 per kilowatt peak. So just with this information, you can sort of assess with your energy tariff what would be your savings and typical payback, simple payback period for your project. And again, the cost will depend maybe if you're implementing the project on the roof, on the ground, or maybe a carport. And also the cost might be a little bit higher if it's implemented on the islands. So last we have the solar PV panels with batteries, so the off-grid applications. In this case, we have to be careful with the quality of batteries. So the battery life expectancy can be about 5 to 10 years, but it can be also much lower with improper maintenance or with low quality products. So it's important to sort of work with a trusted energy service provider so that they can provide quality products and also inform you on what would be the proper maintenance guidance to undergo to extend the lifetime of the battery system. So in this case, the typical simple payback period would be about 4 to 6 years. So that's compared to running a diesel generator to generate your own electricity. And then next. Then we have some slides also to show you how to prioritize energy saving opportunities. And so we can look at first an example for air conditioning. So usually we want to sort of reduce infiltration and heat transfer in the building. So minimize the usage of energy. Then we can improve the control by maybe having programming on the temperature inside the building, and then we can look at changing the equipment for maybe a split AC unit with a high SER to maximize the efficiency. And then lastly, we will look at the solar PV panels and optimize the supply of electricity. So usually, if you reduce the energy consumption, then you will require a lower split AC unit, lower capacity split AC units, and then you'll also need less solar PV panels in the end. So every measure you implement on top sort of affects the measure which is below. So, we have another example for hot water. So again, if you want first to minimize the usage by using the low flow faucets and shower heads and other measures which we saw earlier, then you would maximize efficiency. So maybe adding insulation to piping, and this will sort of lower the amount of heat that's required for your system. So then you can consider the solar hot water. So this will preheat the water, or you could also look at maybe more in industrial processes, but looking at recycling the heat that's being generated inside the building, and then we can look at maybe addressing the boiler, the efficiency of the boiler. So lastly, we have sort of an example here of a hotel, for example, in San Ignacio. So with annual energy consumption of 45,000 kilowatt hour, and we have here a few parameters regarding solar PV panels. So what would be the expected annual energy savings and the cost of solar PV, and we also have the electricity tariff. So if we go to last slide, Maritza, we can see on the left side that if we invest, maybe we invest in solar PV without looking at energy efficiency first, and so we size our solar panel to be 10 kilowatt peak with an investment of 60,000 Belize dollar. We're saving about 37% electricity with this system. But you have a payback period of maybe 8 years with greenhouse emission reduction of 7.2. So maybe the payback is a bit high. So on the right side, we sort of implement first energy efficiency regarding lighting and air conditioning. So the investment here is 16,000 Belize dollar. We do some energy savings. So since we reduced our energy consumption, we can also reduce the size of solar PV panel, which is installed. So in this case, we use 6.8 kilowatt instead of 10. So the investment in solar panels is lower. The total investment is lower than on the left side using only solar PV. We're still generating, in this case, 35% of our electricity from solar PV. But our simple payback period is now 6.8 years, and we're generating even more greenhouse gas emission reduction. So it's a nice example of why you should prioritize sort of energy efficiency before doing your solar PV panel. So this is it. So thank you. I guess Luis will take questions at the end, or okay.
Thank you so much, Mr. Yann. It's a presentation that's packed with information, but I think one of the core takeaways from it is it illustrates clearly the spectrum of technologies which are available to invest in, all with the end goal of making it much more cost effective for you, the business owner, whether it's applying it to your hotel operation, whether it's applying it to business that is operating in the agricultural industry, whether it's a service-based industry business or an office operation. So as Yann shared, we will be providing this presentation to you, so you would be able to better digest the wealth of information which is contained within his presentation.